Yes, so we are making use of the break, what used to be the break, the formerly known thing as a break, for lightning talks that Alice has very graciously volunteered to organize. And so Alice, just
organize and share, right?
Yes.
Okay.
We have just one. So let me put the screen up. And Heidi, could somebody promote Heidi, please? Heidi, raise your hand.
I got her. Yes, I found her, and there you go. She's going to be able to show.
No, she just needs to speak.
All right, she will be able to do that.
Hi, yeah, I can speak.
Yep, go. You've got 3 minutes.
Okay, so hi, my name's Heidi Tiemann, and I'm here from the Open University to talk very quickly about the SuperHorse Variable Star System Science Project. So I've got the poster up here, can't see all of it, so I recommend checking it out later. So many of you will be familiar with SuperHorse. It's been an incredibly successful ground-based search for transiting exoplanets, but the capabilities of SuperHorse actually extend far beyond that to the field of stellar variability. And the SuperHorse photometric archive contains more than 30 million light curves of bright stars with a high cadence and a long baseline. So in my department, we've done a recent reanalysis of that entire archive, which has detected around 1.6 million possible unique periods of variable objects in the night sky. And these are away from the galactic plane on the whole. So there's been previous attempts to classify SuperHorse light curves using machine learning, but these have had varying degrees of success. Instead, we've gone down the citizen science route, creating the SuperHorse Variable Stars Zooniverse project on the Zooniverse platform we've heard about earlier, where we actually ask volunteers to classify photometric phase-folded light curves based on their shape. So it's essentially a pattern matching exercise. In the first 2 years of the project, we've received over 1 million classifications, corresponding to around 500,000 unique light curves. So that's more light curves than objects because sometimes there are duplicates. And the first analysis that we've been doing has found that that 500,000 unique light curves consists approximately of 1/3 of the light curves being real stellar variables that are interesting, and the other 2/3 are junk. But despite all that junk, we've identified around 500 brand new stellar variables, as well as a number of new types of stellar variables, including a new type called a near contact red giant eclipsing binary star system, which we believe may be the progenitor of red novae. And we've also been working on identifying interesting and kind of astrophysically unique systems such as delta Scooties and eclipsing binaries, and multiply periodic and hierarchical systems. So sadly, although the rate of classification by volunteers is really great and the Zooniverse platform is brilliant, to complete this data set, we estimate it might take human volunteers around 20 years. So that benefit of having 1 million classifications and counting so far means we've been generating a huge amount of labeled data. And my colleague, Hugh Dickinson, is currently working on speeding up the classification rate through training convolutional neural networks on images of the light curves rather than the raw data using those volunteer-generated labels. And my other colleague, Adam McMaster, is now in the process of developing a user interface similar to that of the Assassin Catalogue of Variable Stars in order that researchers like you can easily access the science outputs of this project. So we'll be soon publishing a paper on the first data set of the SuperHorse Variable Stars project. And following that, there'll be the convolutional neural network paper as well. So watch out for that. And if you have any questions or want to get in touch, my contact details are there, or message me on Discord. Thank you very much.
Wow, thank you so much, Heidi. That was great.
Well, thank you.
Also, it's a beautiful poster.
Well, thank you.
So that's it. We now have a break.